The mystery of K218b, a new chapter has begun in humanity's long search for alien life. When you gaze into the endless canvas of the night sky, as countless stars shimmer and dance in silence, a timeless question rises again and again. Are we truly alone in this vast universe? For thousands of years, this single question has echoed in the hearts of dreamers, philosophers, and scientists alike. It has shaped myths, guided religions, and fueled exploration across land, sea, and now space. Every telescope ever built, every mission launched beyond our skies, has carried with it the same unspoken hope. That somewhere, out there, another world might hold the spark of life. And now, in the 21st century, humanity has crafted a tool capable of pushing this search farther than ever before. This new age of discovery is defined by the James Webb Space Telescope, or JWST. It is not simply another telescope. It is the most powerful eye humanity has ever opened to the cosmos. Where earlier instruments gave us hints and shadows, JWST delivers clarity. It peers beyond the dusty veils of galaxies, captures faint whispers of starlight, and detects chemical signatures hidden in alien skies. To many scientists, it is not just a telescope, it is a time machine, a way to look back billions of years to the very birth of stars and planets. But JWST is not limited to ancient history. It also has the power to transform our future. Recently, JWST turned its precision and sensitivity toward a single, faint, and distant world, K218b. At first, it appeared unremarkable, just another exoplanet among the thousands we have catalogued. But as the data arrived, a new story began to unfold. K218b resides in the constellation Leo, around 120 light-years away from Earth. To us, it is only a point of light, a tiny shadow crossing the face of its star. Yet hidden within that shadow are secrets that could redefine what we know about life in the universe. A sub-Neptune enigma, K218b belongs to a mysterious class of planets known as sub-Neptunes. These are worlds larger than Earth, yet smaller than Neptune, a category absent from our own solar system. This makes them especially difficult to study. We cannot directly compare them to Earth, nor to the familiar gas giants like Jupiter or Saturn. They occupy a strange middle ground, often described as in-between worlds. Are they rocky like supersized Earths? Are they miniature gas giants? Or are they something else entirely? K218b offers us a rare chance to find out. When JWST examined its atmosphere, scientists were stunned. They detected water vapor, the very molecule essential for rivers, lakes, and oceans. And with water comes the possibility, however faint, of life. But the surprises didn't end there. JWST also picked up methane and carbon dioxide, both gases found naturally on planets, including our own. Still, one signal rose above the rest. A potential detection of dimethyl sulfide, or DMS. On Earth, DMS is produced only by living organisms, tiny ocean microbes that fill our seas with invisible chemistry. If DMS truly exists in the atmosphere of K218b, it could be the most powerful evidence of biology ever discovered beyond our solar system. Orbiting a red dwarf, K218b circles a star called K218, a red dwarf far cooler and dimmer than our Sun. It orbits astonishingly close, just 0.18 astronomical units away. By comparison, Mercury, the closest planet to our Sun, orbits at 0.39 astronomical units. By all logic, a planet so close to its star should be a scorched wasteland. But red dwarfs emit far less heat and light than our Sun. This balance places K218b within what scientists call the Goldilocks zone, a region where conditions may be just right for liquid water to exist. Here, in this narrow band of possibility, K218b emerges as one of the most promising candidates for extraterrestrial habitability. It may not host forests or civilizations, but it could provide an environment where microbial life might thrive in hidden oceans or clouds. And that, for humanity, is nothing short of revolutionary. Because if life can exist on K218b, so different from our Earth, then life might not be rare at all. It might be Hycean worlds, a new kind of planet. To understand why K218b is so important, we must look beyond Earth-like worlds and step into a new idea that is reshaping the entire search for alien life: the concept of Hycean planets. In 2021, astrophysicist Niku Madhusudan introduced a bold theory. He suggested that some planets may not look like Earth at all, yet still be capable of supporting life. He called them Hycean worlds. The name combines two words, hydrogen and ocean. These planets could be up to 10 times Earth's mass and twice its size. They would not be gas giants like Jupiter, but ocean-covered worlds, wrapped in thick, hydrogen-rich atmospheres. Such atmospheres would act like giant thermal blankets, trapping enough heat to keep vast oceans liquid even where ordinary planets would freeze. In some cases, these oceans might cover the entire surface, stretching across thousands of kilometers. A true water world. The promise of Hycean worlds. Why do Hycean planets matter so much? Because they solve two challenges at once. They are easier to detect, and they offer wider conditions for habitability. Their larger size makes them visible to telescopes like JWST. Their hydrogen atmospheres extend the habitable zone, meaning they can support liquid water across a much broader range of distances from their stars. Even at temperatures near 200 degrees Celsius, or almost 400 degrees Fahrenheit, life could still survive in their oceans. Not life as we know it on the surface of Earth, but microbial life, similar to the extremophiles found here. Organisms that thrive in boiling vents, acidic lakes, and crushing ocean depths. For the first time, scientists realized that life might exist on worlds that look nothing like our own. And K218b, with its signals of water vapor, methane, carbon dioxide, and possibly dimethyl sulfide, may be the first real example. JUIC's breakthrough observations. How did JWST uncover this? Through a method known as transit spectroscopy. When K218b passes directly in front of its star, a small fraction of starlight filters through its atmosphere. That light carries hidden chemical fingerprints. JWST captured and analyzed that light, splitting it into wavelengths like a cosmic barcode. In only 5 hours of observation, spread across 2 transits, JWST detected clear signs of water vapor, carbon dioxide, methane, and perhaps even DMS. Each molecule tells part of the story. Together, they form a picture of a world that may not just be habitable, but potentially alive. What comes next? Still, scientists urge caution. The detection of dimethyl sulfide is not yet confirmed. More observations are needed, not only with JWST, but with future telescopes as well. Upcoming missions will allow us to probe deeper into the atmospheres of exoplanets, searching for clearer biosignatures. K218b will remain a top target for years to come. But already, it has taught us something profound. That habitability is not limited to Earth-like planets orbiting stars like our Sun. It may exist on worlds very different, covered in endless oceans, beneath skies heavy with hydrogen. Worlds like K218b. A bigger question: if Hycean planets are common, and early evidence suggests they may be, then the chances of life elsewhere in the universe rise dramatically. Perhaps the galaxy is full of such ocean worlds, each one hiding life in its depths. Perhaps Earth is not the rare exception we once believed, but only one variation in a much larger cosmic pattern. And if that is true, then the discovery of life may be closer than humanity has ever dared to imagine. Sparkles, the story of K2-12B and Hycean worlds, reminds us of one simple truth. The universe is vast, surprising, and waiting for us to uncover its secrets. What lies beyond K2-12B? What other worlds will JWST and future telescopes reveal? We don't know yet. But one thing is certain: the search for life has only just begun.